beautiful morning for a launch in Florida. Five, 4, 3, 2, 1. And liftoff at dawn. The dawn of Orion and a new era of American space exploration.
Well, hello everyone, and welcome to today's Orion post-flight test briefing. Orion launched from Florida this morning at 7:05 a.m. and splashed down in the Pacific Ocean about 4.5 hours later, about 600 miles southwest of San Diego. Crews right now are in the process of recovering Orion. Here to share more about how the flight test today went are William Gerstenmaier, Associate Administrator for Human Exploration and Operations, Mark Geyer, Orion Program Manager, Mike Hawes, Lockheed Martin Orion Program Manager, and astronaut Rex Walheim. We'll start with some opening remarks here, and then we'll have some time for questions. Bill?
Thanks, Rachel. Again, what a tremendous honor for me to be here to really thank all the folks that made today happen. You know, from the United Launch Alliance team that gave us the Delta IV, that gave us the ride to orbit. What a tremendous job they did in preparation and getting the vehicle ready to go fly and to doing their activities and making it look pretty easy. And then to the NASA team and the Orion team and the Lockheed team that just did a phenomenal job of getting Orion ready to go fly, and to see it execute this mission and work as flawlessly as these guys will talk to you about before. And again, I caution us all, we'll dig through the data. The first look looks really good from a data standpoint, but we'll dig through all the data and make sure that everything is there. We'll definitely learn some things from this flight. That's why it was a test flight. It will really help us as we take those next steps into the solar system with humans. And then thanks also to all the folks on site out at California. They're still busy, even as we're sitting here today, picking up the capsule. And the Navy teams and the helicopter teams and the other folks that are out there doing that activity, and is just phenomenal. And even Space Station got to contribute a little bit. The Rapid Scat on board Space Station was able to provide real-time data in terms of the winds, the surface winds at the ocean during the pickup site. So even the station got to contribute to this activity. So what a tremendous team effort. And then I'd like to also thank just a little bit the folks that really got me excited again about spaceflight. I mean, to see the enthusiasm from the folks here at Kennedy and even for the media. I don't think I've been in a press event where you applauded coming in. You're usually sharpening your pencils and scowling at me with grimaces on your face. So again, thank you for catching that spirit that I think we all feel as human beings, that we as a species are meant to push human presence into the solar system, and this is a first step in starting to do that. So again, thank you for getting us excited again and thinking about what it's like to be really a leader in space. So thanks to everyone, and thanks to the team. Mark?
Well, let's see. It's good to see you after the successful mission. It's hard to have a better day than today. It was a lot of fun, very exciting, each part of the mission. Of course, part of the reason it's exciting is it's a difficult mission It's a tough environment to fly through. It's tough objectives that we set for this flight. But it appears that Orion and the Delta IV Heavy were nearly flawless. Great job by the team. Even though I'm an engineer, I'm a fairly visual person, so these are a couple of things that I'll talk about. The things that I remember from the mission were the images. One of the big ones was the Delta IV Heavy, the beautiful liftoff we had at sunrise. Many of you were here yesterday as we talked about the difficulties with getting a great rocket like that started, with the winds and other things that the team has to be very careful about to make sure we're ready to go and have a successful launch. They worked through those things yesterday, and today we got right off, right at the beginning of the window, flawlessly, terrific. And also the upper stage put us right where we needed to be. So I want to thank the ULA team, did a fantastic job. The other images that I remember were that we had a picture out the window. You might remember that one, and seeing the limb of the Earth at about 3,000 miles. What I liked about that view is, one, you can see the frame of the window, so you feel like you're an astronaut yourself. You're looking out the window. It's different than a satellite taking a picture of the Earth. It's what it would be like if you were inside the capsule on that mission yourself. So I thought that was very moving. And the distance we were from the Earth, which a human-rated system hasn't gone that far since 1972. And in fact, that mission was Apollo 17, which launched December 7th of 1972, so almost exactly 42 years ago. So that reminded us that, here we are again now, the United States leading exploration out into the solar system. So that was a great moment. The other two visuals were the separation. We saw the heat shield as we separated, and also the entry, which was very dynamic. I want to thank the teams who got us those views, but you see how energetic the entry is and what the job the parachutes have to do, and it reminds you that this is a difficult job, and those systems have to work and have to work well and have to deal with very dynamic environments. So just hats off to the team. Just a terrific job. So the last thing I would say, and Mike will actually go through some of the specifics about how the vehicle did. This Orion team, this NASA, Lockheed, and other key suppliers, as well as the ground ops team that's doing the recovery right as we speak, and the mission ops team at JSC, who helped us fly the vehicle, and the SLS team who made pieces on this article. They do incredible work every day. Today it's just more obvious to everyone else because we flew the flight and it performed so well. So I want to thank them, and it's an honor, a blessing to be a part of that great team. So I'll pass it to Mike.
Thanks, Mark. So I guess I'll just take from there with Mark. The team has done just an incredible job in it. We had a chance to swing by and check in on the engineering teams who were still in the O&C before we left, and they're the folks on the Orion side that have been not just building the spacecraft, but powering the spacecraft and doing all of the engineering support for the test flight. Several years ago, when Lockheed won this contract, we had embedded in that contract the idea that we were going to build a spacecraft at the Kennedy Space Center, and that had not been done. And we have now done that. We have the team that accepted, just that green pressure hull and added everything else that made that ship fly today. So it is a fantastic team with our suppliers across the country and our partners, as Mark had said. So I really want to thank the teams, including the ULA launch team, that really got us there today. Really just amazing. The Orion was great. Just a very, very clean flight. A few things that were not really unexpected. Our video processing unit reset a couple times. We kind of expected some of the avionics to go through resets. I think we had talked to you about flying through the Van Allen belts and seeing higher radiation than we had seen for a while. So we have to go look at that. When we get to Naval Base San Diego, we'll actually get into the capsule and we'll get those flight data recorders that have that high data rate developmental flight instrumentation that we call it, all of that data. And we're going to actually act to try to get that to one of our facilities there in San Diego so we can start processing that data and get it to our engineering team and the NASA team as soon as we can. So that'll be a big deal. But from the The operational data that we saw today, the ship just flew extremely well, and the flight ops team in Houston really only had to interact with the system a couple times as we went through the day. So it was really a terrific performance. You know, we've talked before, we're already working on that next capsule. We're already forming metal parts, machining parts. We've already sent some parts to ESA for the service module work that they're doing for the next time. So there is an awful lot that is already going, but we'll learn just an enormous amount from what we did today, and when we get all that data back, that will be a big deal for us. You know, we talked a little bit, some folks have asked me what made me nervous, and I went through a couple times and talked about separation events and talked about making sure we got the full burn. So Mark picked out a couple moments. I would say that seeing the fairing jettison was a big one for me today, actually. Being worried about all of those separation events for months and seeing those come off so cleanly was really extraordinary. And then have the upper stage burn that put us on the reentry trajectory absolutely right on the money was really great. But I would also pick on that video feed, and that was something that personally I've really been looking for, is that view so much further than the space station orbit than we've been. And that was really unique to see that. So I'm looking to see more of that when I actually have time to sit and watch the replays. Not quite sure when that's going to happen, but and I would just like to close on one particular thought. Bill and I have been at this a long time together. When we started at JSC, we started with all the Apollo guys still there. So we've kind of now finally done something for the first time for our generation. It's a good day.
Yeah, I'd like to echo the comments I've heard already, and it was just such a pleasure to witness the inaugural flight of Orion. It's an amazing vehicle, and the fact that it went so well is a testament to the workforce that put in so many hours and years of hard work to make this work well. I think one of the memories I have of today's flight was, you know, the Earth limb view was amazing, but I think it was the first video that came down of the Earth, and it wasn't something I didn't recognize. It was something I recognized that view of Earth. It just looked familiar, but then it struck me, that's not from a platform I've been on before. That's from our Orion spacecraft, and that really meant something to me. So that was just amazing. And as impressive as this flight was, this was just serial number 001 of Orion. And as successful as it was, there's just great things more to come down the road, and we're looking forward to that. And I can't wait to get back to work. You know, serial number 002, that one's going to be on the Space Launch System. And I tell you, the sight of the Orion on top of the Space Launch System is going to take your breath away even before it takes flight. And then when it does take flight, America's going to sit up and take notice that the space program is just incredible and it's full of vitality. And then we'll go on there from the second flight to the third flight, and that has a place near and dear to me because our crew is going to be on board. So there'll be 4 astronauts on board the Exploration Mission 2. And the neat thing is that this vehicle is not destination specific. It's going to go to a bunch of different places. We all know the amazing places it can go to. We talked about the lunar vicinity to an asteroid and maybe to Mars one day. And the neat thing about that is this, like I say, is serial number 001 of a storied fleet of vehicles. And when we look back 20, 30 years from now, we can trace it all back to the day where it started out with Orion serial number 001.
Okay, thanks. We'll take some questions, and if you wouldn't mind stating your name, affiliation, and to whom you're addressing your question. Let's start on this side.
Hi, Clara Moskowitz for Scientific American. Just a quick clarification. When you mentioned the reset of the video processing units, was that definitely caused by the radiation, or that's what you're thinking?
We don't have the data to know that for sure, but we fully expected that we'd see some of the avionics boxes go through resets.
And can you talk a little bit more about the performance of the heat shield? Did you get any data in real time about how that was going?
Yeah, the instrumentation for the heat shield is part of this this data that we record on board. So we'll get that down, and we took some photographs, which they're probably starting to look at now. So the first time we really get a chance to look at it is when it gets on the ship in about 4 hours. So we know it worked, but the specifics of how well and what are the subtleties, it'll take more time to investigate. Yeah.
Irene Klotz with Reuters. On the radiation issues again, did you have any indication at all that you did have any of the computer resets that you had talked about a little bit before
The
flight?
only resets that we saw were in the video processing unit, which the flight computers, to my knowledge, we didn't see any issues with. But they're somewhat similar boxes. In fact, we use the video unit as a backup memory for the flight computers.
Hi, Miriam Kramer with Space.com. And not to take away from the celebration of the flawless test flight, but I'm just curious, what kind of things can you learn from this kind of really amazing test flight that you maybe didn't know before, it was on the ground? Like, is this the kind of thing where you really wanted to stress those systems and even see them break, and you could get more data that way?
Yeah, I mentioned a couple days ago that it's an unmanned test flight, and you have to take advantage of that. So you push the systems, you push the operations that you're the most worried about. And again, we have great models and some of the best people on the planet on these systems, but until you fly it, you don't know. So we didn't see anything major, that's clear. It looks like it flew very close to what we expected. But we have 1,200 sensors, thousands of pieces of data that we're going to get back, and I'm sure we're going to find some very interesting things about how it behaved, and that's really important for us as we get ready for the next mission. So
You also gain a lot of data that you can't really get from testing. So just being in the environment, like the GPS system, the global positioning system, at this high apogee, how well it would work, how many satellites it would actually acquire. We have theories, we have thoughts, but it's a function of actual margin through the antenna system and into the receiver and function of the GPS constellation. So that you can't really test. How the vehicle actually flies, we have pretty good computational fluid dynamics to see how it actually performs, how it dissipates heat, energy, what lift vector, what control we can do. They did a little lift maneuver with the thrusters. So all that stuff you could get a good understanding, but this gives you a data point that anchors your models, that says, hey, now these models that we had before aren't exactly right. So there's definitely some things, because I would hear the folks on the loops talking about stuff, how the cooling system was working. They saw some things every 15 minutes was a little different to them. It's just a function of how the vehicle works. You could see the capsule expand as it went to vacuum. So you can see the pressure change inside the capsule, and that's a normal thing. We knew that from shuttle, but then you get to actually see the real numbers with Orion. So it's those real-world environmental complex interaction kind of things that you can't test anyplace else other than to go fly.
And we actually saw things, subtleties that we didn't think about because we didn't talk about as much about the big events in the mission. But, we watched the capsule fly herself, and you watched the thrusters fire. So, you watched all the individual thrusters fire. You saw the propellant use, and you saw how it went to attitude prior to, like the maneuver burns that Bill talked about. So there's actually a great deal of data we got just in the operational nature of how the spacecraft flew.
Hi, Robert Perlman with CollectSpace.com. There was a lot of excitement in the press room when it splashed down, so it was a little hard to hear some of the details. So if you could go over some of the recovery, what we know about the recovery, in terms of did you get all three main parachutes, the forward bay, and what might have happened with the uprighting balloons? Not that they were needed, but
yeah, good question. So the crew actually now remember we had an option, if everything was going well, to sit in the water for 60 minutes and let the systems run, and we were measuring the thermal soak back. Basically, heat shield's obviously very warm, and we wanted to see how that thermal properties soak back into the cabin and how other systems were affected. So we let it do that. So the recovery guys did not go near the capsule for 60 minutes. In fact, I think they just started 30 minutes or so ago to go recover the capsule. We did have them out looking for the forward bay cover and to get the parachutes. The mains were an objective, so we got two of them. Two of the mains were recovered. We knew they sink pretty quick. They're not part of my in my budget. I didn't assume we'd get them back, but we tried to get them so that we could. Sometimes you learn things with the risers and other things that you wouldn't see if you get them back. So we got two of those back. Forward bay cover sunk. If you saw it before we put it on, you realize how big it is and how heavy it is. We were hoping we might get some of that, but we didn't. We'll see, though, on the front part of the CM whether there are any issues with the recontact. Not that we've suspected that happened. As relative to the CMIS bags, a couple, at least one, did not deploy at all. We know one was underinflated, so we're actually looking at the data today. We know that the pyros fired. and the bottles are empty. So what happened with the rest of the bags is part of what we're looking at. But that's, again, a great part of the test. So this one system behaved a little odd, shouldn't have done that. We did land stable 1, which was good. We landed with the heat shield down, and the riser cutters fired, so the parachutes did separate, all the things that we expected to happen. So.
Hi, Ken Kramer for Universe Today and America Space. First, congratulations to everyone. My question is, I wonder if you have heard anything from the president or congressional leaders, and are you hopeful that you will at least get continued and support, and even better, increased support, so we can move a little bit faster? Thanks.
Well, we know we had Senator Nelson was here, and I know on the Twitter feed we've seen some senators and congressmen send their support. So I think just the beginning. We've been busy with other things, but I expect we'll see that a lot of attention relative to that. So we've already had a lot of support. You think about it, it's a bipartisan program. This whole SLS Orion ground ops program is supported by both. We've always believed, and I think with that bipartisan support, you see it, that this is an important part of keeping the United States as a leader in space. And so I think a successful test flight just helps that kind of discussion, I think.
Yeah, I think we didn't get anything. I mean, we got general congratulations from a lot of different folks. It was kind of fun. I got a picture from the service module team in Bremen, who's working on the service module for EM1, and gave us their high congratulations and said they were busy working on the service module for us today. So that was good news on multiple fronts, so that was good. I think the other thing to really watch, too, is you sometimes don't get to see all the work behind the scenes that goes into this flight. So, you need to take a look at what's coming up in future activities. There's a lot of work going on in MAF with SLS that you ought to try to follow. We'll try to make available to you that you can actually see what's happening. We've got the flight dome down there. We'll start some flight welding in January. We've got the shuttle main engines down at Stennis that will actually look at start box condition stuff probably after the first of the year. So that activity is big. We've got the solid rocket motors that are going to be on the SLS firing next year. As Mark said, they're busy machining all the forgings and the key aluminum pieces for the next EM1. Those start getting assembled in MAF fairly soon, I think next year. And then I think the actual welded Orion ends up in Florida by the end of next calendar year here to begin. So EM1 will be here as a pressure shell coming out of MAF by the end of next year, ready to get ready for EM1. So I think sometimes we forget. We see the big event where we can all watch the launch, but then we don't see all this other work. So we're going to try to do a better job of exposing you to what we're doing. Because when I look across what this team is doing, the progress that this team is making across the board is just absolutely phenomenal. I am so impressed with the amount of work that this team is pulling together as a large team to really make this stuff happen. It's just phenomenal. So then we'll try to get that message out, and we've been getting good support, and we'll try to increase the support as much as we can. And I think I get a hearing next week, so I'll get a chance to try to cheerlead a little bit next week in the hearing. So we'll see how that goes. We'll see if we get applause in the hearing or I get the normal press welcome.
Hi, Emily Carney, AmericaSpace.com. Apollo did not have the use of real-time cameras and drones at the time to monitor reentry in the initial stages of vehicle recovery. At present time, how significant would you say has this technology been in today's continued recovery operations and obviously monitoring the vehicle's performance?
A couple of things. So you saw some of the really cool views that we were able to send down, but we also have high-speed cameras in locations like watching the parachutes that are recorded data. So I think high-speed video has been a huge part of our test program, including the pad abort test we did. It was enormous to see separations and the subtleties that go on, so that's huge. What you didn't see was we also had two P-3 aircraft that were following the entry, one measuring the heating on the heat shield so they can actually measure temperature of the heat shield coming in, and the other are following separation events like forward bay cover and everything, taking pictures. So it's huge. I mean, the seeing the pictures yourself is a huge benefit to the engineering team. We're going to get a lot of instrumentation, but when you actually see the operation itself, makes a big difference. And of course, it was also really, really cool today. And I want to thank the ICONA team especially. Yesterday there were some problems. We had fog, it dried, and they couldn't get off the ground early enough, and they had some other things. It was no fault of their own. And I understand they actually they had some technical issues and worked overnight to get that ready for us today. And I want to applaud their efforts because it really helped, I think, put the exclamation point on the mission to see that capsule coming in as fast as we expected it would, and then to see the parachutes deploy. There's really not been a film of that kind of deployment before, and it really gives you a sense for how dynamic that phase is. So I think it's huge.
Amy Green, WMFE Public Radio. I just wondered, I realize, of course, it will take a long time to go through all of the data collected from this mission today. So far, in just the short period since we've had splashdown, what is the biggest anomaly you're seeing already, or what is the most interesting thing that you will be immediately looking at after the end of this mission? And also, just another quick question I wanted to ask about the Orion capsule's transportation back to Kennedy Space Center. I think I heard that it's going to be trucked back, and I just wondered what are the security or safety protocols for that? How will that work?
It will be trucked back. That is the plan. And the ground system development program here at Kennedy is the agent for doing that transportation. And so they've actually gone through and secured all of the transport permits and everything, because you have to do that state by state by state all across the country. And there are unique rules in every state for large hazardous cargo. The craft will still be fueled. It will still have hazardous materials during its transport. So they have worked all of that, the security aspects and the transportation aspects. We expect to get the capsule back here close to Christmas. Would be what the plan would be.
I think the key, rather than picking on anything that acted strangely, our big focus now is to get that data from those 1,200 sensors, and the team is so they can pore over it in the next month or so, because I think that's where we're really going to see things that tell us, as Bill said, tell us about the environment, tell us about how the vehicle behaved, and that's the focus of the team in the next few months.
Let's go to Gina Sinceri, and then we'll go to Frank Mooring.
Gina Sinceri, ABC News. Were there any aha moments for any of you during today's mission? That's something that surprised you and you went, I didn't know that would happen.
We were talking earlier about whether you would let yourself hope that it would behave so well before the flight, right? Because actually you want the team to be trained to handle when it doesn't go very well, and so they can handle issues and work. I mean, we sim this a lot. We simulate these flights a lot, and we simulate failures. So the team is ready. So there was a bit of an aha that it worked so well today. And that's it's a great team. It's a fantastic team. So it doesn't surprise me that this team puts out quality work, because they do it every day. But in that environment and how difficult this test was, that it flew right down the middle. I mean, that was a very pleasant relief. But they did a great job.
Yeah, I think for me the thing that's kind of fun is I understand all the math and all the trajectory stuff, but then to actually see it in real time and see the plots, to see us go from apogee to the really high perigee, the 31,000 kilometers, to actually see that occur and see how fast that's occurring with that Delta IV upper stage really pushing us. And then when you get to that little peak at apogee, spacecraft's flying fairly slow, so that's a fairly long period of time, and then you start the descent down, and the perigee now goes negative, right? So when you're doing that burn, you're actually targeting for below the surface of the Earth. So to really see that in the plot and see the capsule and see the images and then tie that back with the math that I know from all my engineering, putting all that together in one time is maybe not an aha moment, but it's, for an engineer, it may be as cool as an artist appreciating fine art in a museum, right? It's the same thing when you see all the math and all the numbers and you see the visuals and you see the data and you see the plot and you know it's a real spacecraft. All that coming together is pretty special.
Okay, let's go here.
Yeah, hi, Craig Cavalt with Aerospace America. And I'm going to ask a grumpy question. Because Bill and Mike have had so many in the past. A question about the future of the heat shield design. Is the program definitely going to shift from a honeycomb to a monolithic design? And has that been caused by problems with the Avcoat material being applied in an uneven manner?
So we need to get the data from this test before we make any final decisions on the heat shield, because now we've actually flown it. There are things we saw in the manufacturing of the heat shield relative to strength of materials that was a little less strong than we expected it. And for EM1, we needed to make some modifications. We want to understand what happened when we built this last one and look at options for improving it. So that's been work we've been doing since we built this first heat shield. So we'll take that data, we'll take the data from the flight itself, and we'll put it together and make a recommendation as to what to do next. The team, there was no issues as far as unevenness of the heat shield. It was built exactly to the spec, and it's a beautiful piece of manufacturing. But there's something about the material that wasn't quite as strong as we expected in tests we had done before, and so we have to resolve that issue. So when we get to the resolution of that, that'll tell us if we need to modify the design. It might be it's just something we need to do a little bit different about the mixing or how we apply it or how we cure it, something that simple, and then we could have the same heat shield we have today. So.
And I think the other thing we're trying to do here too is, we're trying to build a system that's manufacturable and fairly easy to reproduce again, because we want to keep our operating costs as reasonable as we can, so we don't end up with each spacecraft being, totally unique from a manufacturing standpoint. So we use reaction friction stir weld where it makes sense. They're going to change some of the wiring based on what they learned down here at Kennedy of how you actually lay the wiring in the capsule. So I look at these as pretty positive changes as we actually learn things that are different and we can get better performance out of a different maybe heat shield material. Mark may also get better manufacturability out of a different heat shield design. Mark will trade that. We may even change heat shields even after EM1 or EM2 somewhere in the future, if depending on what the reentry velocity is and what we learn from this test. So I think we need to not think we're getting to the perfect design and then it's not going to change. We're going to be smart enough and nimble enough we can make small changes to keep production costs down and keep our reliability up to keep us with a really safe system. So we'll keep doing those things, and I think we'll learn really a lot from this test as Mark described, and we'll make Mark and his team, whenever they're ready to make those decisions, we're ready to support those decisions.
Yeah, Mike did a real good job a couple of days ago when he talked about we've looked at some of the primary structure, and as we built one, we found a way to actually make it out of fewer parts, right? That helps the cost. We know we've done things to make the structure lighter because we built one and we knew how to do that. Like I mentioned before, the barrel for EM1 is 25% lighter than the barrel for EF2. So those are the kind of things you do all the time. You're improving performance and because of what you learned, either by flying or by building it. So.
Yeah, this is James Tutton with Spaceflight Insider, and I just have a question, well, two questions. One, are there any physical tests that are going to be done on the spacecraft before it gets to Florida, like looking at the heat shield, taking samples or anything like that? And my other question is for Rex. What if some of your fellow astronauts had to say about this vehicle, like as it pertains to like being inside and wanting to fly on it? Thank you.
I'll take the first part, and there's a couple aspects of it that we talked about, getting the data recorders out and being able to process that. We also we have a request from the engineering team to try to take some samples, plugs out of the heat shield. So we're looking at how that fits into the timeline and how many of those we might be able to do. There's a lot of inspection, documentation, photographs, everything of the actual heat shield when we get. But we also need to get it on the road and get it back here for a much more thorough assessment.
You asked about what the astronaut office thinks, and I think you'd be hard-pressed to find an astronaut, past, present, or future, who wouldn't love to fly an Orion. I mean, this is the true exploration that we live for, and it'll be really exciting to have a chance to get on board one of these vehicles.
Okay, let's take a couple more if there are any more. Let's go on the third row here.
Jackie Goddard for the Times of London. To what extent is the future timeline and evolution of Orion and SLS and where it's going and what it'll do dictated by budget? And if you had a greater budget, to what extent could you speed that timeline?
I would say so. It is driven by the budget. But we recognize, recognize where the budget is, and there's a lot of priorities in the country. And so I frankly feel blessed that we have the budget we do, and we have bipartisan support for the pieces for SLS Orion and ground ops, and we need to make the best use of the money we're given. You can see an example of that in that with the DDT, the development budget we were given, we split our development kind of in 3 phases. So EFT1 is the beginning, and it's mostly crew module work, structures, heat shield. EM1 adds the service module, adds more avionics, and starts doing qualification. Then EM2 adds the life support, the displays and controls, the seats, the things that the crew interacts with, and qualifies the full system. So we had to break it up into 3 pieces, and the schedule is part of that, right? Then the next flight on EM1, and then EM2 in 2021. That's absolutely driven by the budget.
And what's, from my perspective, I look at kind of human spaceflight as a whole. So there's a lot of pieces of human spaceflight, right? There's the International Space Station, right, with our crews that are going up to space station, and they fit in the exploration puzzle because, we're learning how the human body performs in space. So when we take crews on missions of 3 years or 2 years duration, we'll understand from space station how the human body performs. Next year we have the 1-year expedition on board space station. We also get to check out like long duration life support systems that can operate with very low maintenance for multiple years. That's part of space station. Then there's cargo that needs to go to station, crew that needs to go to space station. We've got those activities going on. We've got SLS, we've got Orion, ground ops. So human spaceflight is a pretty broad portfolio. When you look at the sum of all those, probably none of them are really funded at the optimum level that they would like to be as individual programs. But if you look at it as an overall human spaceflight program of what we're doing in low Earth orbit, we call it the Earth-reliant region. Then we're going to take crews out to cislunar space. We call that the proving ground region. That's where we're going to learn to operate away from kind of the protection of being hours away as we are on space station. And then eventually we need to get Earth independent, which is a Mars class mission. So even in my directorate, we're funding things that are sitting on the Curiosity rover today. We're measuring the radiation environment of Mars so crews will understand what it's like to go there. We're going to carry a in situ resource utilization experiment that will pull oxygen out of the Martian atmosphere and actually condense it or compress it into a bottle, so we see if we can actually use some of the Martian materials to go push crews into space, so we don't have to carry everything with us. And we know there's water on Mars. We can electrolyze water. We'll use that. So when I look at this, it's this whole portfolio of exploration, and it's tough to pick any one favorite piece and push that piece at the expense of the other. So we've got to look at it as a combined portfolio, and I think we have a really robust overall plan that's going to move us at a reasonable pace as fast as we can with human presence into the solar system.
Okay, let's take a final question from Frank Mooring.
This is Frank Mooring with Aviation Week for Mike and Mark. Is there any way to characterize the amount of data that's still stored in the capsule in terms of gigabytes or something? And also, could you sort of walk through how you're going to distribute it, what the schedule and the process is for distributing it, and whether there are particular data points that you're going to try to pull out early? And finally, if you know, did the P3 get the IR data on the long distance? Thanks.
Haven't heard about the P3, although we know that they acquired.
I did hear that they did. Yeah. They followed it all the way to the ground, so we'll see what the data looks like. Yeah.
So we talked about the DFI. There were 1,200 sensors in that DFI. Now, most of that data is sampled at a much higher rate. The normal operational instrumentation is usually on a 1 cycle a second, 1 hertz rate. The DFI data is typically at a much higher sample rate, so that we can really pinpoint some of the phenomena that do that. Our schedule to get the data, we actually, per the terms of the contract that NASA had with us to do the test, we owe them a report in 90 days after today. And so that's why we want to get the data and get it out of the capsule as soon as it's back to port, and start actually working on that data. And as soon as we have the data processed, we'll be sharing the data with NASA, but then we will be doing our own analysis of that data and what it means for these individual systems. That'll be the core of that report that we have.
There's actually experts on the ship. We have thermal protection system experts, computer experts, forward big cover experts, pyro experts. So they're when this thing gets on the ship, they're going to be looking at it right away, kind of at a macro level. Hey, this is the kind of things we see. But as Mike talked about, that data in those computers is really the key in seeing specifically how it experienced the flight.
Okay, well, that's all the time we have today. I'm also told that the White House congratulated the team at the start of a president's briefing today. Let's take a look at the highlights from today's flight test. And again, just want to thank everyone for joining us.
Beautiful morning for a launch in Florida.
AC is go. RC. Clear to proceed. Launch director. This is the launch director. You have permission to launch.
Five, 4, 3, 2, 1. And liftoff at dawn, the dawn of Orion, and a new era of American space exploration.
Just a few miles away from reaching peak altitude. Again, this dramatic view of the limb of the Earth from one of the flight test cameras in the crew module of Orion.